Okay, we're going to be talking about the basic graphs and how they move with numbers. So if I have a number, if I have a y equal x to the fourth, which you know is basically a parabola, touching here at the origin, if I have plus 1, it shifts it up by 1. If I have y equals sine x, which you know that's a basic sine x graph, if I have plus 2, so way down here, which was at -1, if I add 2 to it, then it's going to start at 2, go up to 3, oops, let's fix that a little bit, go up to 3, right, and come down to 1 and come back to here. So it shifts it up by 2. Okay, the x to the 2/3 graph is this cuspy thing, and then subtract 1 moves it down by 1. So it looks like something like that. 1 over x, you know, looks like this. So 1 over x minus 3 moves the asymptote that was here down to -3. So it looks something like that. So you know root x graph looks like this. So root x minus 4 is going to shift it to the right by 4, kind of the opposite direction. Here's ln of x, right? And that's where 1 is, and it's got an asymptote here. So if it's ln of x minus 1, you're going to want to shift it to where the asymptote is here at 1, and then it's going to cross here at 2. All right, if it's on the inside and we've got addition, we move to the left. So y equal x cubed, you know, looks like this. So to the -2 is going to look something like that. 1 over x squared, you know, looks like this. So if it's x plus 4 squared, the asymptote's going to be at -4. And so it'll both be like this. Right, ln of x, you know, looks like this. It's really important, you know, the asymptotes there, and there's 1. So it's going to reflect it across the y-axis. So this graph will be like this. Still has an asymptote there, crosses at -1. You know, the e to the x graph looks like this. So e to the -x flips it over the y-axis, so it looks like this. In both cases, they cross here at 1. X to the 1/3 looks like this, right? It's the inverse of x cubed. A negative in the front flips it over the x-axis, so that would look something like this. Cotangent, you need to know. So here's at pi, crosses here at pi over 2, and there's another asymptote here. So if it's negative, flipping over the x-axis, then this will be here and here. The asymptotes don't change, right? They're still here and here. Okay, so putting together piecewise defined functions is putting together pieces of different graphs. So I'm going to try and draw y equal x cubed over here, like that. And I want the piece of this graph that is smaller than or equal to 1. So looks like that. So I'm going to make a solution graph over here, and I know the y value would be 1. And so it looks like that. And then 1 over x cubed, got to know your basic graph, that's like the hyperbola. And I want when it's bigger than 1. So from this point out, and that y value happens to be 1 also. So here says don't include, this one says include, so include wins. So that's the piecewise graph. 1 over x cubed, we just did that, right? So 1 over x cubed looks like this. The part of it that's less than 0 is this whole thing. I'm going to make my solution graph over here. And then x to the 4th, you know, is the parabola-ish looking thing. So it's going to start here at 0 and go up. Ah, I did tell you what that was, right? So the square root of x squared is another way of saying the absolute value of x. So to graph the absolute value of x, it looks like that. Here's -1, and I want to take that open hole and back further. So -1, that'd be the y value of 1. And then x to the 2/3 again looks like this. So here's -1, and that's at the y value of 1 also. So we're going to pick up that part and go here. So this closed means include. So I'm going to include and make it look like that. Oh, what's going on here? That looks like the absolute value again. So that first graph looks like x minus 2 over the absolute value of x minus 2. I think that reminds me of that graph. Only 0's not the bad point. I think 2 is. So let's just try and plugging in a couple numbers. What happens when I plug in 3? I get 1 over 1. If I plug in 1, I get negative 1 over 1. So it's 2 where it changes. So I'm going to put 2 here. If I plug in 3, I get 1. And so then here's 1, kind of open circle and out like this. And then if I put in 0, if I put an x value of 0 in here, I get a negative 1. So all numbers less than 2 give me a negative 1. So it's that graph, only 2 is the place that it changes between 1 and negative 1. And this says when x is 2, it has the y value of 3. So we have a filled in dot up there.